Hi guys, welcome to PowerLearn once again. In this video, we are to prove that the sine squared of theta plus pi on 4 plus sine squared of theta minus pi another pi on 4 is equal to 1. So let's just call this whole thing as our left hand side and this is our right hand side. So we are proving that the left hand side is equal to the right hand side. Like you do always, I will be very glad if you pause the video, try your hands on that, then you compare your solution with the solution I'm about to provide. Then also, if you are new on this channel, welcome, and I'll say that if this is the kind of content you are looking for, please don't hesitate to subscribe to this channel. Thank you in advance for doing that. Now, to proceed to this problem, we have to know that generally if we have sine squared A, this is the same as sine A all squared. So I'm going to apply this principle to rewrite sine squared into bracket theta plus pi on 4 and sine squared into bracket theta minus pi on 4. So sine squared into bracket theta plus pi on 4 is the same as sine into bracket theta plus pi on 4 all squared. So in this case, the A is the theta plus pi on 4. So this plus, once again, this gives sine into bracket theta minus pi on 4. All these squared. Then what we are going to do here is that we are going to apply one of the trig properties, which says that if we have sine into bracket A plus B, this is the same as sine A cos B plus cos A sine B. So I'm going to apply that to expand what is inside the parenthesis, where in this case the A here is theta and the B is the pi on 4. So this is the same as expanding this gives sine theta cos pi on 4 plus cos theta times sine on pi on 4. So all these plus, I'm now coming to expand what you have here. Now to expand what we have here, we are also going to apply sine into bracket A minus B is the same as sine A cos B minus cos A sine B. So this gives me sine theta cos pi on 4 minus cos theta times sine pi on 4. So this gives me now pi on 4. Remember that pi here is 180, and so 180 divided by 4 is 45, and cos 45 is root on 2 according to the calculator. So this gives me root on 2 sine theta. But before I proceed, lest I forget, this whole thing is squared. This whole thing is squared. Yeah, because the expansion, what you have here is only the one in the parenthesis. So I forgot to bring the squared. And this is also squared. So sine theta cos pi on 4. Cos pi on 4 is the same as cos 45, and cos 45 is root 2 on 2 times the sine theta, plus sine 45, which is the pi on 4, is also root 2 on 2. So root 2 on 2 times cos theta gives root 2 on 2 cos theta. Now remember that all this is squared, plus, now this will also give root 2 on 2 sine theta minus another root 2 on 2 cos theta, but all this squared. So I'm going to expand the brackets using the principle. If we have a plus b all squared, this is the same as a squared plus 2ab plus b squared. So using that to expand this gives, but remember that our a is root 2 on 2 sine theta, and our b is root 2 on 2 cos theta. And so this is going to give me root 2 on 2 sine theta all squared plus 2 into brackets root 2 on 2 sine theta times another root 2 on 2 cos theta, plus root 2 on 2 cos theta all squared. Then I'm going to use another principle which says that a minus b all squared is the same as a squared minus 2ab plus b squared, to expand what we have in this bracket. And so that gives, so once again our a is root 2 on 2 sine theta, so this gives root 2 on 2 sine theta all squared minus 2 multiplied by root 2 on 2 sine theta multiplied by root 2 on 2 cos theta, then finally root 2 on 2 cos theta, everything squared. So expanding from here, that is simplifying what we have here, gives us root of 2 on 2 squared gives us 2 on 4, and 2 on 4, so I'm going to get 2 on 4 sine squared theta plus 2 times root on 2 times another root on 2. Now root on 2 times root on 2 is 2 divided by 4 times 2 gives us 1, and sine theta times cos theta gives us sine theta cos theta plus another root on 2 squared. So root on 2 squared gives us 2 on 4 cos squared theta plus root on 2, the root on 2 all squared gives us another 2 on 4, then the square will also affect the sign, so that gives us sine squared theta minus, now we have root on 2 times another root on 2 times 2, which gives us -1. -1 times sine theta cos theta gives us negative sine theta cos theta, plus we have root on 2 cos theta all squared. So that gives us, now root on 2 is 2 divided by 4. So 2 on 4 cos squared theta. So breaking this one down gives us 1 on 2 sine squared theta plus sine theta cos theta plus 1 on 2 cos squared theta plus another 1 on 2 sine squared theta minus sine theta cos theta plus 1 on 2 cos squared theta. So breaking this one down, we have sine theta cos theta and we have minus sine theta cos theta. So these two will cancel out. Then also half sine squared theta and another half sine squared theta gives us 1 sine squared theta. So we have sine squared theta plus we have half cos squared theta and another half cos squared theta, which gives us cos squared theta. But from one of the trig identities states that sine squared theta plus cos squared theta is equal to 1. And by this, it shows that what we have on the left hand side is equal to what you have at the right hand side. Thank you for watching this video, and please don't forget to subscribe to this channel.